for his science, for his art, and his entertainment. And we asked Michael to give a family lecture this September in honor of Coast Weeks, which is a month-long celebration of coastal activities. And so tonight, Michael will be introducing you to the science, wonder, and art of seashore life. Michael is a graduate student, was a graduate student in Woods Hole at the Boston University Marine Program, and he was one of the founding faculty members of Falmouth Academy back in the late 1970s when the fledgling Falmouth Academy was formed and what was it, the basement of Woodbriar, which on Gifford Street. He chaired the Science and Musical Theater Department at Cape Cod Academy for 7 years. He has co-authored nearly 24 science textbooks. He's the author of half a dozen commercial books that range from thinking puzzles that are in the Children's Museum, Cape Cod Children's Museum, they're wonderful books, to hands-on science activities. He's worked in Jordan as part of the Middle East Peace Accord, helping our teachers to develop non-gender biased and critical thinking materials. He wrote an award-winning national curriculum on teaching HIV on AIDS curriculum to middle school and high school students. And his project, The Science of HIV, was nominated for an Emmy in Outstanding Programming for Children at the 1998 Daytime Emmy Awards in New York City. This evening, he'll be sharing with you some of the activities he's working on with Seashore Life, and I'm sure you'll be quite pleased and entertained at Michael's presentation this evening. So without further ado, Michael DiSpezio.
Thank you. Well, I trust everybody's going to be engaging their thinking skills tonight, and I think we're going to have a pretty nice time. I should mention the wonderful artwork that you saw before that was on the screen was done by Tessa Morgan, who's sitting up here. Tessa is a fantastic, Tessa, she is an unbelievably talented woman who has great artistic skills, who is working with me on a project to put together, I just got the note that my mic is not on, to put together a set of educational flashcards for people so that they're able to identify the creatures that are found along the seashore. Okay, let's see where we are. The science, art, and wonder of seashore life. I'm honored to have this turnout here, especially having a whole bunch of younger people as well. I've taught for many years and I love teaching. A couple of things you're going to have to watch. If I get excited about a topic, which I am about teaching and I am about science, I tend to go faster and faster and faster. Just tell me to slow down. Although I'm in the Northeast Coast right now, so it's a lot easier as opposed to when I present down in Louisiana where everybody's going, slow down, Michael, you're going to hurt yourself. And it's a fun concept, but if I tend to be accelerating, just give me a nod and I'll put myself into a slower gear. There are several challenges with presenting on the science, art, and wonder of seashore life. One is to present so that the sophistication reaches everybody. As you can look around, we've got some pretty young people here, which are probably about 3 years old, and we have some older people who are more than 3 years old. And to hit their sophistication, I'm going to be trying a number of different techniques, and I beg your understanding if something begins to be a little bit too advanced or if something begins to be a little bit too repetitive. But again, I want to try and meet everybody so that everybody goes back with a fair understanding of seashore life. A couple of other challenges. Traditionally, a presentation on seashore life has been mostly a passive one, where a facilitator speaks to an audience about certain types of marine life, and then we'll have them, invite them, in fact, we're going to be doing that later, up to take a look at the actual pieces. I want to try and make this a little bit more active. If one looks at national science standards and where the teaching of science is going in the United States, there are a number of tenets which are expressed in how teachers should approach the area. And one of them is to make it exciting, to be active, where students are no longer passive acceptors, but they actually actively construct their understanding. Also, there's a tendency towards looking at more understanding than knowledge. Knowledge people can access. You can look on a CD-ROM. You can turn on a television. You can read a book. and access knowledge. However, what do you do with the knowledge? How do you apply it? How do you appreciate it? How do you evaluate it? Well, hopefully I will meet all those in the presentation that we do here. Now, I've got a disclaimer. My first disclaimer has to do with something called classification. Classification with how you go about organizing and classifying, grouping certain organisms together. I have sincere apologies to Louis Agassiz. Louis Agassiz was a scientist. He was a naturalist who was Swiss-born, came to the United States, worked in the late 1800s on many different types of species. He, in fact, was one of the founders of the Museum of Comparative Zoology up in Boston, up in Harvard. And Louis Agassiz, I'm apologizing for to Louis, because the classification I'm going to be talking about today is going to be representative of the official scientific classification. We're going to be talking some common classes. We're not going to be focused directly on specifics of taxonomy. That's another lecture in itself. So we're going to be jumping around with that. So if I don't hit a certain group, and somebody here is a specialist in chitin anatomy, amphineurids, oh, you didn't cover that group, understand we're having a fun time. I also want to apologize to Louis because that is a picture of Charles Darwin. I could not find a picture of Louis Agassiz, so sorry, Louis. And Louis was interesting. Probably one of the interesting things about Mr. Agassiz was that he was working at a time when there was no television, so he could really apply himself. And just an odd thing I just looked at, there was a recent survey talking about television and saying that the average child now watches about 6 hours of television per day in the United States. 6 hours. What a block of time. But there's something that we may be able to access. Yeah, oh, we've got some. He only watches 2 hours. Oh, great, great. So we've got, and I probably am addicted as well. But let's talk about television for 1 second, because we're going to play a game. When I mentioned the actor's name, Richard Dawson, does that bring to mind anything? Anybody know who Richard Dawson? I believe his name was Richard Dawson. Hogan's Heroes. You remember him from Hogan's Heroes. And he was on Hogan's Heroes. He played the British chap that was part of the Stylog. Later on, he went to fame with a TV quiz show called Family Feud. And Family Feud had these people that were calling out certain concepts which were addressed in a survey. First, a survey was given out to a number of people, and they responded to the survey, and then you had these two contestants from different feuding families, the Hamadid family over here, and maybe the Corleone family over here, and they would both have to guess what the results of the survey was. And what I'd like to do to start off today is work with some of the younger kids here on our survey, and we're going to take that. It's just an introduction. Now, I've worked with several middle schoolers and actually some elementary students on talking about what their favorite crabs were. And they gave me 5 favorite animals. I want you to think about the favorite crabs that you see on the seashore. And we're going to see what you come up with. Let's see. Who's going to be my first volunteer? Who's got a favorite crab? What's your name?
Spider crab.
Spider crab. And what's your name?
Nick.
Nick. You got one. Nick's got one. And Nick, let's see, spider crab. Spider crab is right here. We've got it. Okay, somebody want to give me another one? Yeah.
When I was in the Caribbean, I saw crabs about this big.
So crabs about that? Neat, crabs. Have you found any up here? Up on the beaches? If you walk along the... Hermit crabs, perfect. You've got one right there. And not only do you have one, but you have the number 1 on the list. So we have hermit crab and spider crab, 3 more different crabs. Think of all the crabs that you've seen before. Want to give a shot?
Fiddler crab.
Fiddler crab. Do we have fiddler crab? Yes, we do. Fiddler crab. Boy, I didn't realize everybody knew their crabs so well. We've got 2 more spaces for favorite crabs. Let's try that young gentleman right in the back who's holding the cookies. Big crab, like a king crab, right? That big, like that, like the biggest crab you can find, like a king crab. If you were in New Jersey, you'd be calling these things king crabs. However, if you're on the Cape, what do you call the king crab? Like when it's at your brother's house? What kind of crab was that? A blue claw. Oh, boy. Blue claw. And we've got him. Boy, well, it's in the family. You guys have it. And we need one more crab that was on the survey. Let's see, who has not given one? We're going to go right back here. Yeah. Japanese marsh crab. That's a good one. And that's a real neat one. That's an exotic one. And if John Galois was here, he'd be applauding you for picking a neat exotic species. However, we're going to hold off on that one. And actually, that's one of my favorites, too. This is a more common one. So people who are not familiar with it, and the hints out there, they're called king crabs, and they're big crabs. They're big, kind of, and they've been around for several 100 million years, and they're really not true crabs. What are they? Horseshoe crab. Excellent. Excellent. So now we have our crabs down. We've got quite a few different crabs. Hermit, fiddler, blue claw, spider, and horseshoe. And just to drive this point home, let's take a look at one more survey. And this survey is on your favorite legless shellfish. It's a shellfish that doesn't have any legs. So we're throwing out a big group of shellfish, which we'll get to in a second. What are the favorite shellfish? What kind of shellfish do people like to eat? Think about the ones that are up there. We're going to try you right there. Steamers. Do you like steamers? Ooh. We've got somebody who likes steamers, and guess what? You're right on the list. Perfect. All right, somebody's going to give me another one. Another shellfish. Just think of all those shellfish. We're going to try you right up here. Scallop. And scallop is on the list. You've got another one. We're going to do another one. Another shellfish. Yeah. Shrimp. Oh, shrimp are a good one. Shrimp or shellfish. But shrimp, which is on another survey that I have, tend to have what? Legs. But if we took the legs off the shrimp, then it would be okay, but we're leaving the legs on the shrimp for this part. Let's see, what are some other? Think about what other types. There's a real common one that's out there. Want to try again? Blue mussel. Excellent. Look at this. Boy, everybody's getting one. We only have two more spots. One is the most popular one that most kids know about on Cape Cod, and the other one is not so popular. Who wants to try the popular that hasn't given me an answer yet? You have not. Little necks. Boy, where are we from? New York. See, I learned it as little necks when I was growing up, but little necks, everyone, no, they're not little necks. They are called here quahogs. So we have a little smaller, is that correct, Dale, on the little neck? Just making sure that I'm getting all the stuff. By the way, this is Dale. Dale works for Sea Grant, and he has brought in materials for hands-on touching in the tanks later after we talk about the organisms. But we've got one more up here right now. We have one last favorite. What's going to be a favorite? Favorite shellfish. Oh, you haven't given one, Nancy. Which one? The clam. Actually, if we look at these, I should have had clam. Quahog's a type of clam. I'll give you a hint on this. Do you like pearls? Oysters, there we are. You like pearls except when you're eating oysters, and it's the last time you want to find one. And what we have is a number of different species. So we've talked about quahogs, blue claw crabs, let's see, hermit crabs, scallops, spider crabs, oysters, fiddler crabs. Let's throw a couple more things out here. Squid, mussels, slipper shells, barnacles, horseshoe crabs, sea stars, sand dollars. Look what's on the beaches here. We've got a ton of stuff on the beach. What do we do with it? Is it easy to understand? Look at that. It looks like a big mess. That's the word that I'm looking for. It looks like my room when I was growing up. Back home, it's a mess. What are we going to do to the mess? Yeah.
Clean it up because oil pollution smells.
We're going to clean it up. Actually, we're going to go right into cleaning up that mess, and we're going to clean it up the way that scientists tend to clean up messes. They tend to organize things. And the organization we're going to look at is an organization called taxonomy or classification. In fact, most everyone here should have some shells in their hands. And why don't you take those shells out? If you do not have shells, please come right up here and just take a selection of 5 different shells. Now, when one looks at shells, one uses their senses to study the organisms. And what I'd like everybody to do while these other people are picking up their shells is to study your organisms. And I want you to look at the different features that are on the shells and separate them into two groups. Look at the features that are on your shells and separate them into two groups. Okay, so everybody is separating them into two groups. What I'd like to know what I'd like to find out is what characteristic, what feature of the shell did you select to separate those into two groups? Remember, when you're separating something in groups, you're not only observing, but you're looking for similarities and differences. What are some of the similarities and differences, or what feature did you use to separate them into two groups? Who wants to help me out with their set of shells? All right, we've got a couple of volunteers here. Actually, let's go right on the edge here. We're going to move that way.
I separated my shells into big and small.
Excellent. Big and small. Who else separated them big and small? All right, we've got a couple people that did that. Excellent. So we had big shells and small shells. Somebody give me another feature. What other features did you use to separate those shells? What other features? If you didn't have big and small, what else could we have used? Yeah, what did you do?
I separated them whether they had ridges or no ridges.
Whoa, whether they had ridges or no ridges. How many people did ridges or no ridges? Right, oh boy, what type of potato chips do we have here? All right, so we have ridges and no ridges. Anybody figure out another way to separate them? There's more than two ways? I'm lost here. Let's try it right there.
Colors.
Colors, excellent, excellent. So separating on colors, how many other people did colors as separation? Very nice, good observing. What are some other ways? Anybody else still have any other ways to separate them? Yes.
Sorry. Soft.
Say again, I'm sorry?
Rough and soft.
Rough and soft, neat. So you're using other observational skills. You're using observational skills, touch, to find out the difference. In fact, there is a wonderful story about a biologist who works with mollusks, and this man is blind. And he's able to tell differences by just touch. So it's an incredible sense. That's great that you found that. Anybody else use any other things? Yeah.
By the front, so they were by the shape.
By the front, by the shape. So by holding them by one way, you're able to look excellent by the shape. How many other people did shape here? Shape. Good, we got a couple. What we're getting at, a whole bunch of differences that you're able to apply to separate groups. Now, when most scientists work with organisms and look at separating them, they're using some of these characteristics, but they also use other types of characteristics. What they come up with, and it's a mess, but get rid of the mess right now, is a way of breaking up organisms into different groups. The basic groups are the kingdoms. So we have the animal kingdom, the plant kingdom, the protist kingdom. We have these different large groups. Within the animal kingdom, we have a number of different phylum or major groups. And these are some of the groups we're going to touch on today. First one is the periphery. These are the sponges. This group over here, fancy names in Iderian, that's what the jellyfish and their relatives belong to. The ctenophores, platyhelminths. We've got many different types of groups. And within these groups, you know what we have? More groups. Groups. And within those more groups, you know what we have? More groups and groups and groups. So we've got a lot of stuff for developing groups. And if we can have that first slide. Now let's begin to take a look at how these organisms and the grouping applies to some of the pieces that we have on the Cape. The first group that I want to talk about are the sponges, the local sponges. And Sponges are interesting because when people think of sponges, they often think of the commercial sponge, the one that you clean yourself, the little pinkish, and wondering, how is that thing alive? Well, that thing was never alive. Those commercial sponges are manufactured. However, you can go to certain stores and buy real sponges. Next slide, please. And in fact, the sponge I'm going to start off with is Creona, which is the boring sponge. And I picked the boring sponge for a couple of reasons. First of all, what's life like as a sponge? Boring. Think. Boring, right? Very good. There is a sponge. Sponges just kind of just sit there. And what do? They pass water in and out. For many years, scientists didn't know whether sponges were animals or plants. Later on, they found out that they had more similarities to animals. They had things that animals have, as opposed to what plants have. Now there's still questions about sponges, but those have to do with whether the sponge is really a multicellular animal, or is the sponge really a whole bunch of little cells which come together and work together. In fact, you can take a sponge and pass it through a very fine screen and break the sponge up to its basic building blocks, those little cells. What those cells will do is they will come together and reform the sponge. Incredible concepts with sponges. This one, the boring sponge, got its name not because of its interesting lifestyle during the winter, but we have a sponge which bores into shells and actually eats away the chemical which makes up those hard shells. Next slide, please. This is another common sponge that you can find attached to pilings. And you can find it in the intertidal area. In fact, we've got a piece here, Dale picked one up. It is redbeard sponge. And how do you think it got its name? Kind of looks like I look like Louis Agassiz now. Or not Louis Agassiz. Who was the man that I had up there? Charles Darwin with a red beard. Next. Sure.
How does a boring sponge bore?
How does a boring sponge? It releases chemicals, and what I believe it's probably an acid base, because what you're doing is that you're breaking up the calcium carbonate and little holes. Is that the? And so the specific acid, this is a great place to ask that. Is somebody know what the acid is or the compound that it does? But I've got some pieces later of shells that are completely riddled, and it's great looking at that, all those little holes in there. Next group, as we move up the food chain, and we move up the evolutionary ladder, we get to a group called Coelenterates, or the Cnidaria. Now, this group is a little bit more advanced than the sponges. Instead of looking like this amorphous mass, this kind of mass of cells, this tends to take on a certain symmetry, takes on a round or a radial symmetry. Next slide. And the Coelenterates can be found in a number of different classes. We've got jellyfish, sea anemones, coral, hydroids. These are very different from each other, yet how are they alike? Because there has to be something similar that you classify them together. And what you find out is that all of these Coelenterates have a stinging cell. They have a cell which has a little trigger out there and kind of a whip behind it. And if something comes and touches, excuse me, can you touch that finger over there? The whip goes out. When you're able to activate that cell, that nematocyst, it shoots out a whip. At the end of certain whips, there are little toxins, there's poisons. In fact, if you go to certain jellyfish and you touch them, what happens? You get an ouchie. They sting. They sting because their whip is long enough to penetrate the layer of skin. So they go through your skin and they inject that poison. Now, like many poisons, the poisons that are in nematocysts are protein-based. Now, protein's a type of chemical similar to the steak that you eat. Say you have tough steak. Steak is tough. How can you make steak softer if you're going to be cutting it? What can you do to steak? You can tenderize it. You can put different meat tenderizers. A1 men tenderizer sauce. Probably put ammonia in there, but that probably wouldn't do anything for the taste. But you can start putting a whole bunch of chemicals in there. What those chemicals do is that they chop up the protein. They make the steak literally weaker. In fact, you can put A1 sauce on jellyfish stings or ammonia, and that will chop up the toxin and will stop it from stinging. Kind of little interesting facts which are connected to this. Okay, next slide, please. As I mentioned, this group, of which these jellyfish are members, have this radial symmetry. They've got this round symmetry. Next. Some coelenterates are found on hermit crab shells. In fact, we've got some in here that have that. They have what's called pink snail fur. Hydractinia is the fancy name for it. And this is a hydroid. And if we looked close up at that little fur on that, you'd find that there was these little stalks. And at the end of the stalks, there were tentacles, and there'd be all stinging cells. And what would happen when somebody would touch the stinging cell? It would sting, and it would sting little pieces of food that go by in the water column. Now, it's kind of interesting because there are studies on hermit crabs which show that hermit crabs prefer to live in a shell which is covered by these stinging organisms. Can anybody figure out why? Why would a hermit crab, I'm a hermit crab and I need a shell. I got to go take a shell, and there's a shell over there that doesn't have anything on, but there's a shell that has stinging stuff. Which shell am I going to take? What's the advantage of going for a shell that has this stinging stuff already on it? Oh, I don't think I've heard from you yet. It's like armor. And not only is it like armor, what can those stinging cells do? It can protect it. Excellent. So the hermit crab actually borrows the protection by getting in the shell which has built-in stinging cells. Great. And that is snail fur. And we have some snail fur on these pieces that Dale brought in. Next, please. If you looked close at many of the hydroids, you'd notice this wonderful arrangement. It almost looks like flowers. But again, here are the tentacles, and they have the stinging cells upon them. And we have reproductive masses, and we have these stalks. Next one, please. This is the lion's mane jellyfish. How many people have seen one during the summertime around here? How many people? They sting and they hurt, and they're pretty nasty. Lion's mane. Some lion's mane can get pretty big. How big is the biggest jellyfish somebody has? Anybody ever find a jellyfish this big? Bigger or smaller? Bigger. This big? Bigger? This big? See, I'm in Woods Hole. Now everybody's going to go down. Bigger, bigger. In fact, these things can grow so they're at least 7 feet in diameter. 7 feet. That's a pretty big jellyfish. You can feed a whole school on peanut butter and jellyfish sandwich or something like that. All right, so we have a jellyfish with stinging cells. Next, please. Anemones. This is a great anemone. These anemones, you can find them on rocks. They have stinging cells. If you touch them, they have this great muscle which contracts everything back into the body. Next, please. Next group. The next group of organisms are called comb jellies, and comb jellies are out in the water, and they're a little bit different from true jellyfish, although they tend to look like jellyfish. Instead of having stinging cells, these guys have sticker cells, and they can shoot out these threads that have sticky things on the end and kind of like stick something and bring it back in and eat it. Next one, please. This is a common ctenophore, pleurobrachia. It's a little small, little gooseberry, little jelly-like piece that you can see in the water, and it can actually bring in these tentacles, bring them out, bring them down, and off these tentacles you have those little types of cells which can send out those little sticky threads. Next, please. Miniopsis, and we have another comb jelly which is up here. This one, you can notice that there's rows of comb plates. These comb plates are wonderful to watch. In the light, they iridesce, and you can actually watch waves of the iridescent go because it's used for motion. So what you have is a whole bunch of these little plates just beating, and you can watch the beats go down. Also, you may have noticed this organism during the summer. It is able to give off a glow. It's able to fluoresce, and you're able to see that in the evening. Next, please. All right, moving up the animal kingdom. Now we're going to leave these organisms behind which don't have heads to ones which begin to have heads. Now, the development of heads, cephalization, having a head area, is a real important step in the evolution because by having a head, I'm able to test the environment before going into it. So it's almost like going into a new room where, well, let me check out this room to see if the water temperature is right, if there's enough air, if there's all sorts of neat things. And if I'm able to test it with part of my body and it's good, then I bring my whole body in. And that is the advantage of seeing when we begin to go into animals which have head regions. Next, please. And this is a clamworm found locally. If you go digging around clams, you're lucky not to get bitten by one of these. Also, people who fish tend to use these as bait often enough. When the worm is agitated, it can evert. Almost like taking, you know how you could fill up a water balloon and you squeeze on one end of the water balloon and the other end goes out even further? The same thing goes on with its mouthpiece, except at the end of the mouthpiece isn't this nice soft rubber, but it's these two hard jaws that can pinch you and bring an organism of prey back into the mouth. Next, please. Spirobus. We have another shell, and the shell is found on seaweed, often on seaweed, on rocks sometimes. And we have the little organism lives in here, sticks out its feathery gills, and then can retract and seal us up. Little protective cave that it lives within. Next. Okay, next group. The next group are the mollusks. The mollusks are real important animals. Economically, they're very important on the Cape, as most of you, said that there was mussels, oysters, quahogs, quite a few different types of mollusks of economic import. Mollusks themselves have an outer, hard, tough skin. This skin can sometimes secrete a covering, which is a shell, and that's what protects the mollusk. Next. There's many different types of mollusks. There's the gastropods, which if you translated that meant stomach-footed. And the gastropods are animals such as snails. They have a single shell. Then you have the bivalves, the pelecypods, the other fancy name for it. Bi meaning that there's two shells. Other groups include cephalopods, the head-footed ones, such as the squid. Then we have nudibranchs and chitons, but we're not going to talk about all of those. Next. These are the different types of mollusks that you can find. Here's a common one. It is the eastern oyster. And the oyster, I put that one up there first because it's kind of neat, because if you're lucky, you can get an oyster which has on the inside a little pearl. And what the pearl is the oyster's way of making an unpleasant situation a little bit better. Have you ever tried to sleep in a bed that had sand in it? If you ever tried that, it's kind of annoying. If you sleep on the beach or something of that, if there's a little bit of sand, you want to get rid of the sand. What the oyster winds up doing is it coats these irritants with a real slick, glossy, hard surface, and that is what the pearl is. Next. We've got whelks. And whelks, this one is the knobbed whelk, are great shells to watch, especially if you can find live ones, just going through eelgrass beds and stuff as they trudge right along. It's incredible. And the whole body gets withdrawn right back into the shell over here. They often leave egg cases, and I don't know if we have some of their egg cases in there, but the egg cases are wonderful little pieces of, I'll draw a picture of it later so you can see what those egg cases look like. But they're often washed up along the shore. Next, please. Okay, we've got moonshell, and this one secretes another type of egg case, which is almost a collar that forms around it. Next. Crepidula, and the boat shell. I believe most people here probably picked up a boat shell as one of their different shells early in the evening. And the boat shell, as you can see, has a little shelf that's right in there. And these are incredible little organisms. The boat shells are often found in a mass, in a clump. You can get 10, 15 of these boat shells together. It's kind of interesting because the boat shells, when you look at them, they, like people, have different sexes. The boat shells, which are generally on the bottom of the stack, are females. Those on the top of the stack are males. What they believe happens is as another boat shell lands on top of one beneath it, it stimulates the one on the bottom to basically change from testes to ovary production, and it becomes then an egg-producing machine, where the ones on top then begin to fertilize it. So you can find those little clumps, they're sometimes called harems of boat shells. That's crepidula. Next, please. Soft shell clam. Great tasting steamer, Maya. real common in the area. Its shell is very soft. This organism cannot withdraw and get itself protected by the hard shell. So it becomes very vulnerable to certain types of predators. Next. The quahog, Mercenaria mercenaria, Latin for money, money. Why was it called money, money? We've got the purple ridges over here, which were used by Native Americans as wampum, as currency exchange. So that name kind of stuck with these clams. Next, please. Blue mussels. Mussels, kind of an interesting thing. They, unlike these other clams, don't live in the sand or in the mud, but they attach with these hard threads onto rocks. Those hard threads, those byssus threads, are being studied because sometimes those chemicals can offer clues to scientists about what makes a good cementing, or in this case, a dental compound. Next. The scallop. And here we have a bay scallop having those ridges which give it extra structure. Next, please. Oh, I should mention something about the scallop. When you think of a scallop in these clams, and other types of clams, you tend to think that they're just sitting right there. These and also ocean scallops are great swimmers. And scuba diving, sometimes as you're scuba diving, you can sometimes get a whole bunch of these things swimming by you, and they clap up and down and they dance in the water column. It's one of the strangest things to see. There are stories, in fact, that people going into scallop beds where the scallops kick up so much sand and silt that the divers cannot see. But it's great watching these little things which don't look like they should be able to swim. And they're swimming sometimes is caused by a predator which comes in the area, and they're able to see the predator. They have all these pearly blue eyes which look out, and they're not able to see distinct features, but they're able to get shadows and figure out if something's coming around that they don't want to be there, they'll swim away. Next, please. The squid, cephalopods, very bright organisms. The ones around here aren't as big as the ones one sees in science fiction movies, but these common squid are very important. They're very important to scientists for a number of reasons. One of them is that years ago, much was learned about the human nervous system by studying the giant nerves which are in these squid. A couple of things about the squid. The squid has a siphon right here, a hole that it can shoot out water, and it can jet propel itself in the other direction. There are reports about its behavior, which is interesting, because if you look at a squid can change colors. While you're watching a squid, you get this flush of colors that goes over its body. If a squid looks like it's got to get out of the place, that it isn't a real good place to hang out in, it can do a couple of things. When a predator comes by, the squid will change colors. As it changes colors, it can emit ink, and the predator then loses its mark on the squid itself and goes for the ink, and the squid kind of gets out of there. Next, please. Jointed-legged, the arthropods. And the arthropods all are similar because they have a hard exterior, like lobsters, like crabs, and they have jointed legs, and the legs actually move out. Next, please. And examples of these arthropods are crabs, lobster, shrimp, barnacles. Barnacles are arthropods. They kind of look like they should be clams, but they're not. If you've ever watched a barnacle is kind of like taking a crab and gluing it on its back. And as I'm not going to do it, I just realized I've got the mic here, but on its back and kind of kicking food into its mouth. And if you look closely, when they open up, you can see all these little legs which come out, these little jointed legs. An incredible thing. You can see them in tanks real well. If you watch barnacles feed, you watch the legs come out, and they have this motion which sets up water currents which kick food into their mouths. Last one on there I have is the horseshoe crab. The reason the horseshoe crab is not placed in with the other crabs has to do with its anatomy, with its evolution, that the horseshoe crab is more closely related to things like spiders than it is to regular crabs, and it has to do with the way the mouthpieces are formed and the way the mouthpieces work. Next, please. The blue claw crab, nasty but very tasty. And you can see right here a couple of things about it. Take a look at the last set of legs, which are up. Tessa did a great job on that showing. Those are the swimmerettes, and they're used for swimming, whereas the other legs are walking legs. These are other ways of telling the difference between these animals. Next. This one is the fiddler crab. And the fiddler crab, the male fiddler crabs have a big claw, and that claw is used to display certain types of things, territory, courtship, and if you watch them, they actually do this intricate movement. They'll bang it on the substrate, they'll bang it on the mud, they'll pick it up, they'll raise it, they'll do all sorts of things in different types of behavioral displays. And they live in sand or in mud. They collect the mud and sand and run it through their mouth, and they eat the little pieces of algae that are on those. Next. Anybody ever see one of those? Yeah, they're kind of neat. Mole crabs. And mole crabs you can often find just their shells, almost paper-thin shells on the beaches up at North Falmouth. I found quite a few of those these past few days. But these are mole crabs, and as the waves break, you can sometimes see waves retreating, and as the water goes out, these little things scurrying. They're about the size of a thumb here, a little bit smaller than my whole thumb, and they just burrow right into the dirt. Next, please. Oh, we have the hermit crab. Hermit crabs don't have their own hard outer shell which protects their abdomen. Instead, they have to borrow a shell, and this one is borrowing a shell here which is encrusted by a couple of other different organisms. Next. Pea crab. It's one of those feelings when you're eating mussels or you're eating a type of organism, something else is in there. Well, sometimes pea crabs can be found in different types of mussels. And the pea crab lives inside of that mussel and feeds on little scraps of food. I don't believe there's tissue in that. I've got to look that one up to see what the direct relationship is. Next, please. The horseshoe crab. Horseshoe crab has quite a few different eyes. Although it only looks like it has this eye and another one on the other side there, there's some median eyes and little spots, so it's able to pick up bearings from moonlight and also from the sun. And the horseshoe crab, as we talked about before, doesn't relate very closely to those other crabs, closer to things such as spiders. Next, please. Oh, by the way, I should mention on a horseshoe crab, you shouldn't be afraid of that spike at the back. It does not sting. They're not stingers. And that spike, basically, it's not hollow, but there is nothing in that which can hurt you on there, although the edges of the spines can be sharp. Next, please. Lobster. This one could hurt you, but they taste good. We have a lobster here. Again, the body form has this front area which has some of its segments fused together, and then you have these little segments coming out down the bottom. You can find those locally, and you can also find them quite frequently at fish stores where the lobstering people will go out and catch lobsters and then bring them in under correct size. Next, please. Barnacles, I mentioned those before, also arthropods. Next. Spiny skinned. We're getting to the last couple of phyla here. The spiny skinned animals are the echinoderms or the echinodermata. And this next slide will show a typical, we've got a couple of different types of spiny skinned animals. Sea stars, sea cucumbers, sand dollars, and sea urchins, all which what we have up here in the tanks. Next. Sea urchin, purple sea urchin, very good. And the purple sea urchin has those spines which protect it. It also has these little tube feet that if you watch them in tanks move, you can watch these feet which have little suckers on the end move the organism along. Next. Sand dollar. Notice that in these types of animals, again, we have that radial symmetry, that symmetry around a circle. In this case, it's around a 5-pointed star. Next. Sea cucumbers. All right, and sea cucumbers also have those sticky feet down here, and they have this branchy type of tentacles, which actually, as they go out, they capture food, and they bring them in and lick their tentacles to get all the little food bits that are stuck to them off. Next. Sea star, starfish. And this is Astellas, this is the common one. This piece over here, which is sometimes called the starfish eye up there, is not an eye. It's probably the remnants of an old filtration system that evolutionary used to be able to take water in through that madreporite is a fancy name for it. So it is not used for seeing. However, if you turn over a starfish, often on different species, if you look right here at the tip end, you're going to see a little red eye spot, or you'll see an eye spot. Next, please. Brittle stars, very pretty serpent-like stars. As their name suggests, they are brittle, and their legs can break very easily. You can find them under rocks. And again, when you're out looking for these animals, it's important to return the rocks to the direction that they were in. You don't want to expose organisms to their predators if you don't have to. Next. All right, the tunicates. This is finally, we're in the phylum Chordata. Next, please. And the tunicates, these things are closer to us than the other organisms that we've looked at tonight. And it's kind of interesting because you look at a sea squirt and wonder, how can the sea squirt be like a human? You begin to see certain types of similarities, and the similarities have to go with their little developmental stages, which look like tadpoles. These organisms also have a strong supportive rod in their back like we do. They also have gill slits at a certain stage of their development. And the last type of chordate I want to mention is kind of an interesting one, and I think that that is it with the slides. And this final chordate is that one right there. And that final chordate is people. Interesting part of the seashore. This, by the way, is a message which was sent out from the Arecibo dish back in the 1970s, a radio telescope which sent out to distant worlds some things about Earth. In here, you have a code which describes certain basic atoms. This blue thing, you know what this blue represents? DNA. It's a double helix, and then we have a person down here. And by the way, embedded in here are a number of prime numbers. Anybody that hears the word prime number these days tends not to think of elementary school, but instead thinks of what movie? What movie? Anybody see it? Contact? The movie Contact, which was an interesting piece. In fact, that's how we have Carl Sagan in down here, talks about prime numbers, and prime numbers being very different from other pieces that we have. All right, in conclusion, real important. I want to get back to Louis Agassiz for a moment. Louis Agassiz from before had a great saying, study nature, not books. And in fact, what we want to do is invite everybody up here to take a look at the sea tanks. And if I can get the help of Dale and maybe a few other people, we're going to take a look at excuse me, some of the different organisms that are here, some of the shells. If you have questions, we can talk about them. In addition, the project that Tessa is working on illustrating, on putting together a set of educational flashcards, and we have some of those images that have been printed out onto beach walker sheets. So we have sheets which we'd like to offer. Everybody can leave with one of these sheets. They have the organisms on one side and activities on the other, also samples of the cards that are available through Sea Grant. And let's see, I believe there are some other handouts that people will get as they leave. And on that note, I guess I want to bring it to closure. Any questions? Actually, why don't you, if you have questions, I'm going to be around. You can ask me those questions now. And otherwise, I believe that we're ready for closure. Is that? Okay, well, thank you. If you have questions, come on up. If you want to hear more stuff, the touch tanks are right up here. If we can have the full lights, we'll have everybody looking at that. And we've got these handouts sheets.
Do you give back the shells?
No, you can keep the shells. All right. Here you go.